let's find the center of mass of a conical band. Z squared equals x squared plus y squared. So this is a cone, but we'll only be interested in z between 1 and 3. And then this will have density given by delta is 1 over z. So using symmetry, the x and y coordinates of the center of mass are both 0. So we only need to find z bar, the z coordinate of the center of mass. So first we'll parameterize our domain. So we'll take C of r theta will be x is r cos theta, y is r sine theta, and then if z squared is x squared plus y squared, then z is just equal to r. So r will go between 1 and 3, since that's our bounds for z, and z is r. And theta, as usual, will go between 0 and 2 pi. Okay, so now C r cross C theta is, let's see, so cos theta sine theta 1, and then negative r sine theta r cos theta 0 I j k. So that'll be, let's see, so for I we have negative r cos theta I. For j, so it's negative, but then we have two negatives. Okay, so minus r sine theta j. And then for k, we've got so cos squared plus sine squared plus rk. And so the magnitude of that, CR cross C theta, is, so here we'll have an r squared and then another r squared, so I have r root 2, and so d sigma is this dr d theta is r root 2 dr d theta. So now we can find, we need to calculate the mass and the first moment with respect to the xy plane. So the mass m is integral over s of delta, the density d sigma. So that's integral theta from 0 to 2 pi, r from 1 to 3. The density is 1 over z, but z is r, so this is 1 over r times, and then d sigma is r root 2 dr d theta. So the r's cancel, and so we just have to multiply root 2 times 2 pi minus 0 times 3 minus 1, so this is 2 pi root 2 times 3 minus 1, so 4 pi root 2 is the mass. We record that. So then next we need to figure out the first moment. With respect to the xy plane. So this will be mxy integral over s of delta times z d sigma. So now we have a similar integral, but now we have another copy of a copy of z in here. So now we've got r inside. So now this will be, I guess we could pull out the root 2 and the 2 pi. So this is 2 pi root 2 integral from 1 to 3 of r dr. So this will be 3 squared minus 1 squared over 2. So that'll give us 8. Or this will give us 4, but then we also have a 2 over here. So this will give 8 pi root 2. So mxy is 8 pi root 2. All right, so now we get the z coordinate of the center of mass is m xy over m is 8 pi root 2 over 4 pi root 2 is 2. So the center of mass is x bar, y bar, z bar is 0, 0, 2, which is the point drawn here.